Hi peeps, this is page 1 in your chemical reactions packet. I'm just going to go through it and help you fill it out. So if you look, first of all, there's an example equation right here, and it's showing a single molecule of methane reacting with 2 molecules of oxygen gas, and they form 2 new things. The atoms all rearrange each other and form these things during the reaction. 1 molecule of carbon dioxide gets formed and 2 molecules of water get formed. And if you look down here at the count, methane's got 1 carbon and 4 hydrogens. 2 oxygen molecules are 4 total oxygen atoms, and this single carbon dioxide molecule is 1 carbon atom and 2 oxygen atoms, and 2 water molecules is 2 oxygen atoms but 4 hydrogen atoms. Because of this 2 there, it multiplies through, so there's actually 4 hydrogens. It's essentially saying there's 2 waters. So if you look at these 2 waters, obviously you can see there's 1, 2, 3, 4 hydrogens. So that's where the 4 comes from. So this equation is what's called balanced. You look on either side of this arrow, either side of this arrow, and you start with 1 carbon, you end with 1 carbon. You start with 4 hydrogens, you end with 4 hydrogens. You start with 4 oxygens, you end with 2 plus 2, you end with 4 oxygens. This is a balanced reaction. Okay, so let's look at these other parts and fill out this table. Maybe you're already able to fill the table out on your own. So what symbol in a chemical reaction or a chemical equation is used to separate 2 or more reactants or products? Ooh, you know what? First, let's define these 2 things. Let's come back up here. Write this on your paper. The things on this side of the arrow, these are called the reactants, because they're the 2 things, or 3 or 4, or just 1. The number of reactants can vary. They're the things doing the reacting together. And then on the other side of the arrow are what are called products. And same thing, you could have 1, 2, 3, 4, endless number of products. Okay. So the thing that's separating them from each other are these plus signs. And it sort of means end. Kind of has the meaning end. So this end that, and this end that. Next thing, what symbols used to separate the reactants from the products? That's our arrow. So arrow. And the arrow literally means yield, or forms, or turns into, decomposes into, produces. Sometimes I just say makes. Okay, and now there are some other symbols on here. They're actually not shown in this equation, but I'll show you what's meant by them. So oftentimes you'll see an S, and a lot of times it'll be in parentheses, meaning that whatever molecule you're talking about is in the solid state, and in liquid. So solid S, liquid is an L. I usually use a lowercase l because you can't mistake what it is then. Gas is a G, and aqueous, meaning mixed with water, is an AQ. So if we come back up here, methane, at room temperature, methane would definitely be a gas, so there could be a little lowercase g next to it, and oxygen would also be a gas at room temperature. And then after these 2 gases reacted with each other, what they would form is carbon dioxide, which would be a gas, and the water might be a gas at first, but it would, at room temperature, it would pretty quickly condense into a liquid. So we'll put a little L there for the water. One other really important thing that this page highlights is what are called diatomic molecules. When you write chemical equations, one really important thing is to pay attention to certain elements that are never written alone. So if, in other words, up here in this one, when we talk about oxygen, you don't just, oxygen's never written just as an O, as the single atom, because oxygen doesn't float around in the air as a single atom. It floats around bonded to another oxygen atom. And there are 7 elements that do that. They are hydrogen, hold on, I don't have a periodic table in front of me. So hydrogen over here, and then fluorine, chlorine, bromine, iodine, oxygen, nitrogen. Okay. Nitrogen, oxygen, fluorine, chlorine, bromine, iodine. Sometimes people say that these 7 elements, if you look on the periodic table,